right, so hopefully you took my advice and you went ahead and FOILed this out, and if you did, you've got the first terms multiplying to be x squared, the outsides to be 9x, the insides to be a negative 5x, and the last ones to be a negative 45. And when you combine the like terms, negative 5x and 9x from the outside and the inside, you see that you got the exact same answer that I got in my shortcut version. So let's try the shortcut version again here. We see we have just an x term, constant terms, constant terms. So I know my first term is going to be an x squared term. My inside term, my middle term is going to be a negative 4 plus a negative 3, which is a negative 7, and those are x's. And then my last one, a negative times a negative, which gives me a positive, and 4 times 3, which is 12. And let's go ahead and FOIL that out one more time so that you can see that. So FOILing it out, we get x times x, which is an x squared, x times negative 3, which is a negative 3x, negative 4 times x, which is a negative 4x, and then finally a negative 4 times a negative 4, negative 3, which is positive 12. And then the outside and the inside terms, they're going to add together, which ends up being x squared minus 7x plus 12. And you see that's the exact same answer with a lot less work, with a lot more work than what I did before. All right, why don't you go ahead and give this one a shot on your own. So just pause the video and see if you can do it in the shortcut method. And I'm going to do it in the shortcut method right now. All right, so I get an x squared because I see they're both x's, and then I have a 7 and a negative 9, which gives me a negative 2, and I know those are x's, and then I'm going to multiply those two constants, negative times positive is a negative, and 9 times 7 is 63, and that's my final answer. Now if you FOILed it out, remember FOILing's fine, we have x times x, which is x squared, those are my firsts, and then x times negative 9, which gives me a negative 9x, and then a 7 times an x, which gives me a positive 7x, and then a 7 times a negative 9, which is a negative 63, and when we combine these two middle terms, the outside, the inside, that's going to give me a negative 9 plus positive 7, which is a negative 2, and that's a negative 2x, and then minus 63, which is exactly the same answer that I got. Now, one of the reasons that I teach doing the binomial times a binomial and the method that I'm showing you, the shortcut method, because in doing this, we're talking about the factors of the 63 that give us sums and differences of the middle term. And that's exactly what we're going to need to do to factor these things later on. That's the undoing of sum, is factoring. So we're dealing with the product of these numbers that give us a constant. Those are the factors of that number, and it's those factors that give us a sum or difference of the middle term. And so we're kind of establishing that early on because that's something we'll need. Now we're going to talk about some problems where we have an a times the x with an outside number and an inside number, and a b times the x with the outside number. And in this case, we're going to get the variable squared term in the first one, but we also have that a times that b multiplying and becoming its numeric coefficient. And then the middle term in our trinomial that's resultant from a binomial times a binomial of this type, that comes from the a times the outside number and the inside number times the b being added up to go along with the variable. And then the last term, still the product of those two last numbers. So let's go ahead and take a look at these. So in this one, in simplifying this, what I see is 1 times 2, which is 2, and those are x squared, so I don't even consider. And then I say, okay, 1 times 3, which is 3, and then negative 5 times 2, which is a negative 10. And that's going to give me a negative 7x, and then negative times a positive, which is a negative 15. Now, before you watch the next video, I would invite you to go ahead and FOIL this out and see where I got my numbers by doing a FOIL method.